everyone. Today, we're going to break down a really interesting piece of material. That's right. We're going to fully reconstruct Kevin Deierling at Computex 2026 at the Taipei International Computer Show. It was a truly jaw-dropping keynote. The core idea of this talk is called extreme co-design. You know what? This concept basically completely overturns our past understanding of data centers. It tells us how to build a true AI factory. Seriously, this decision isn't just a hardware upgrade. It's really a living, breathing computing revolution. Okay, before we dive in, let's quickly look at today's 5 key points. We'll start with what a paradigm shift is, then go straight into the underlying architecture, looking at the energy layer first, and then move up through the second and third layers, chips and infrastructure, and then the fourth and fifth layers, models and applications. Finally, we'll wrap up with a super cool idea that agents are the workforce to wrap things up. Follow this blueprint, and we can understand how NVIDIA is taking the entire AI infrastructure and rebuilding it from the ground up. All right, let's jump into part 1, the paradigm shift. Are you all ready? Because the world of computing has really changed. First, the most important mindset shift. You see, traditional data centers used to be for executives, plain and simple, just a cost center. You had to spend a ton of money on hardware and power, so software can run on it. But AI factories are completely different now. An AI factory exists to make money. Its only mission is to generate tokens as efficiently as possible. In other words, it becomes a token revenue generator. The more tokens you produce, the more business value you create. That's a completely different game. So you might ask, why do we have to make such a massive architectural shift? The answer is, in this number 10x, the parameter scale of today's AI models is exploding at 10x a year. Keep in mind, 10x every year, that's not a slow incremental upgrade. It's flying. Within just a few years, compute demand will grow to a level we can hardly imagine. This insane demand, if you still want to rely on the old way of just stacking more and more servers, I'm telling you, there's no way that holds up. So how does NVIDIA solve this problem? They proposed a framework called the 5-layer cake. This is basically what I just mentioned, extreme co-design. Their approach is wild. It's not just about making a chip or writing software. It's about optimizing 5 layers: energy, chips, infrastructure, models. There are also 5 layers of applications, whether within each layer or between layers. They optimize everything with no blind spots. Next, let's move to part 2. That is the bottom layer of this cake. Layer 1, energy. In the end, power is the foundation of everything. No matter how fast your chips are, how much an AI factory can actually do, still comes down to land, power, and the physical limits of the building. Kevin Deierling 在演讲里 used a very down-to-earth analogy. He said it's like the heavy downpours in Taipei. AI training creates huge current spikes. That's right, the kind of afternoon thunderstorms we're always dealing with. Traditional cloud computing in the past had very steady power consumption, but AI training is different. When tens of thousands of GPUs run in sync, like a supercomputer, they can suddenly draw a massive amount of power and then just as suddenly drop off. This kind of extreme, unpredictable power storm is a real nightmare for the grid. So what do? To solve this problem, they turn DSX into something like the operating system for an AI factory. It runs like a smart reservoir. When power demand is low, it stores the extra energy. And when one of those sudden power spikes hits, a sudden spike in power demand immediately releases power to support it. With this precise peak shaving and valley filling approach, which basically means under the same 1 gigawatt power cap, this AI factory can actually pack in 40% more GPUs. Well, this isn't just about saving power. It means you can generate more tokens and turn that directly into real revenue. Okay, the foundation is set. Let's keep moving up to the third part layers, 2 and 3. Let's look at the chips and how it works together with the infrastructure. In today's AI factories, just making the world's most powerful chip is honestly nowhere near enough. NVIDIA connects its latest Rubin GPU with the Vera CPU through an ultra-fast coherent interconnect, locking them tightly together. A a total of 7 different chips linked in the rack with the NVLink, and then extended across the entire data center through the Spectrum X network architecture, spreading out like casting a net, as if thousands of chips were fused into a single superhand with one shared brain. So what does this kind of extreme hardware co-design actually deliver in returns? Listen, it can produce more than 10x the token output. Even more shocking, it cuts the cost of generating each token to just 10% of the original. Think about it, 10x more performance, but only 10% of the cost. In any business, that would absolutely be a game-changing innovation that wipes out the competition. But to get all these chips to actually play nice and deliver 10x10 level performance, your infrastructure has to keep up because of the physical limits of cable transmission. We have to pack those dozens of GPUs as tightly possible into the same rack look with density this high. Traditional fans just can't dissipate all that heat. So the entire power and cooling system has to be rebuilt from the ground up. What we're seeing now is a full shift to liquid cooling using 400 volts or 800 volt high voltage DC bus bars. It also uses the unified MGX standard. Only by going to that level can you truly turn 72 GPUs into one complete supercomputer. Speaking of that, there's another critical technology, signal transmission. In the past, we used copper traces on circuit boards to carry high-speed signals. The signal would degrade badly, like when you talk too far away and your voice gets quieter. You'd have to spend a lot of extra power just to push the signal through. But now it's switched to Spectrum CPO. That's what's called co-packaged optics. It directly puts the optics components right next to the ASIC chip. The moment the signal comes out, it turns into light. Not only is the quality perfect, it also eliminates the hassle of signal restoration. Just that alone saves tens of megawatts of power. And seriously, it's insane. That wraps up the hardware. Let's quickly move on to part 4, the 4th and 5th layers, and see how all of this powers the upper layer models and applications. Actually, we just talked about all this super cool hardware, liquid cooling, optical tech, and the only reason they exist at such great expense is to serve the layer above them later on, those massive, complex AI models. And the way this perfect hardware, software integration works is absolutely insane. For example, the latest DeepSeek open source model, you don't even have to change a single line of code, just run it on the optimized Blackwell and run on the Rubin chip architecture. Performance can skyrocket 30x. Exactly. So that's the power of bottom-up co-design at work. And at the very top of this 5-layer cake are the applications we've been talking about. Through the CUDA-X libraries, NVIDIA has turned this layer into the sweetest frosting. It can speed up all kinds of specialized work, whether you're doing QLitho chip design or running scientific simulations that are so complex, they're almost impossible. That ensures that from the very bottom of the hard silicon chips to the software at the very top, the whole ecosystem can work together very smoothly. Okay, next we are moving into the final section, part 5, agentic workforce. Take a deep breath for a second, because this may be the most mind-blowing idea in the whole talk. Here's the key point. The way AI operates is already completely different from what we thought. We used to think people had to give the command first. In other words, you give it a prompt and then the AI, right? But now, agentic AI is talking directly with other AIs. They can read data on their own, pick their own tools, and even plan several steps ahead for their actions. In other words, they completely bypass the slowest part of the whole process. The slowest part of the whole process. That's right. Us humans. That creates a fully self-driven, super closed loop system. But if you want AI to think autonomously, it has to have memory, right? Just like humans do. Agentic AI needs very fast short-term memory to understand the conversation happening right now. And at the same time, it also needs massive long-term memory to look up the knowledge it learned before. To solve this problem, NVIDIA specifically built a new storage architecture for these AI agents. It includes CMX, which handles short-term memory, as well as the SHTX system for massive long-term memory. This kind of design, tailor-made for agentic memory, is purpose-built. The results are truly astonishing. It increased token throughput by 5 times, and overall efficiency also improved 5-fold. What does that mean? It means these AI agents can not only think more complexly, make decisions, but also react with extreme speed, far beyond traditional limits. So how will this powerful agentic system actually change our world? Let me tell you, it definitely won't stay in servers. It's going to move into the physical world. Whether it's robots in factories, precision equipment in hospitals, self-driving cars on the road, or even satellites flying overhead, will all be able to reason and act on their own, not to mention things like coding automatically. You can imagine from digital to physical, almost every industry is getting ready for this unprecedented agentic transformation. At the end of the talk, Kevin Deierling left behind a very striking and even a slightly provocative question. When this new generation of AI factory workers are moving at lightning speed to reason on their own, to plan and act, how exactly should your human team adapt? That's a question well worth thinking about. I hope today's full breakdown of this talk helped everyone see the real shape of this tech revolution more clearly and start thinking ahead about how we should find our place in this new era of agentic AI. That's all for today. See you next time. Bye-bye.